Welcome to Control4 Driver Development Essentials. My name is Peter Cosenza. In this video, we're going to step away from APIs, system architecture diagrams, and driver code to consider an important part of driver development that is often overlooked, the user interface, commonly referred to as UI. All too often, driver development is approached from a command or function-based perspective. While the significance of device control through well-executed code should not be overlooked, it's important to keep in mind that the interaction users have with your device occurs largely through a user interface. When we refer to user interface, we use it as a general term referring to any manner in which a user interacts with the Control4 system. And we're not just talking about in-wall touch panels here either. There are many ways in which a user can potentially use your driver. But before we get too far into discussing UI devices, there's another important term that you'll need to understand, and that's Navigator. Navigator refers to any instance of a Control4 UI running on a device or through an application. You can think of Navigator as the engine that delivers the interaction layer between the user and your driver, and it resides on every device that provides a Control4 interface. User interaction with your driver should be encouraged through as many opportunities as possible. In order to support this, Control4 provides several types of navigators that you should be aware of. These include List Navigator. This is a text-based navigator that you'll find on Control4 system remote controls. By the way, List Navigator can be localized through the use of our Language Development Kit, or LDK. Flash Navigator. This is the graphical control interface displayed on touchscreen and monitor-type devices. Android Navigator, which refers to the Navigator instance running on devices using the Android OS platform. And finally, iOS Navigator, which provides a UI on devices running Apple's mobile operating system. So let's recap what we've just discussed. We know what a UI is, and that is provided through an architectural platform named Navigator, and that Navigator comes in several different flavors to support a wide variety of Navigator devices. There's also one other means of user interaction that we need to discuss. It's not as graphical as the previous types, but it can be just as useful. I'm referring to programming UI. Programming user interface is an instance of user interaction that does not rely on a graphical or text-based level of interaction. Generally speaking, it is implemented through system programming, button presses, timers, or events. While programming UI isn't quite as flashy as the Navigator version, it offers a useful way for a user to interact with your driver. To get a feel for what's involved with the programming user interface, let's go into Composer Pro and take a look at a driver that takes advantage of this type of user interaction. A good example of programming UI would be keypad button presses to control a device state. Let's say that we've created a driver to control a motorized projection screen. If we look at a simple project that contains our driver and a keypad, we can use programming to create a UI that does not involve a graphical interface at all. In using the button press programming in Composer Pro, a user can interact with my projection screen driver. In this example, pressing button 1 on the keypad will lower the projection screen. Pressing button 2 will raise the screen. Both of these commands are defined in my device driver. At this point, our user can interface with their projection screen via its driver and some keypad programming. These are very explicit means of controlling the screen. Now, let's take our programming further and build some user interaction based off of a device event. If we consider the actual powering on of the receiver as an event, we can build even more interaction. Say, for example, when the user turns the receiver on, our programming interacts with our projection screen driver and lowers the screen. And we can include even more implicit interaction. In this case, it's based off of our screen lowering event. In this example, when the screen lowers, we'll reduce the lights in our TV room to a preferred TV viewing level. Of course, all these commands are available through a graphical interface on a touchscreen or a mobile device. However, it's useful to consider these types of UI scenarios when developing a device driver. To reiterate, as a driver developer, it's important to consider ways that the user could leverage your device driver to interface with their home or business. You are in a unique position in being able to deliver device control as well as offer the power of personalization through a wide array of devices, such as keypads and touchscreens, to iPads and big screen TVs. Considering these types of user interaction before creating a device driver will help to ensure your driver will be well accepted and successful.